Hello everyone, I'm that anime theorist Jordan, and I know it's crazy, but I genuinely believe that this tennis ball is one of the fastest objects in anime history.
But how could a tennis ball be faster than Mashle, Killua, Zenitsu, Koro-sensei, and even Gojo?
And what modern shonen could produce such a magical tennis ball? Black Clover, no. Chainsaw Man, no. Fire Force, no. Spy Family, no. Actually, yes? Spy Family, which is surprisingly shonen, accidentally produced a tennis ball faster than every single one of those characters. But how did Spy Family, of all shows, produce a tennis ball that broke the concept of physics? Well, it all started with Yor's simple tennis game against Lloyd's coworker Fiona Frost. Also known as Nightfall, Fiona is a fellow spy who worked alongside Lloyd at Wise. In this instance, Fiona and Lloyd were put on a mission requiring them to enter and win a billionaire-funded underground tennis tournament. Whew, that is a mouthful. Anyhow, after successfully completing their mission, Fiona finally meets Yor after dropping off Lloyd. After witnessing Yor's charm firsthand, Fiona enters a fit of jealous rage as she wants old Lloydy boy all to herself. So the freshly crowned underground tennis champ does the only reasonable thing to assert her dominance, and asks to play Yor in a quick tennis match. Now, I'd love to sit here and address how Yor absolutely shredded that tennis ball, but let's not get distracted as Yor's second attempt to hit the ball was not only humanly impossible, but accidentally created one of the fastest objects in anime history. So let's break it down. How fast was the tennis ball traveling? We can use many different references to see how fast the ball was moving, from concrete ripping up to the dent made in the tree. But we can start on the low end with the most basic and upfront information. Fiona claimed as the ball was approaching her that it had to be moving at least Mach 1. So let's jump into it. What does Mach even mean? According to a little astrotech company called NASA, the measurement of Mach is the ratio of the speed of the aircraft to the speed of sound. If a tennis ball is flying less than Mach 1, it is going subsonic. Flying over Mach 1, and it's going supersonic. And if the tennis ball is sitting just right at Mach 1, it is considered transonic, or exactly the speed of sound, which is 767 miles per hour. But that's not nearly fast enough to outdo my main man, Koro-sensei's Mach 20. So what else can we do to infer the speed of the ball? If we take a closer look at the tennis ball approaching Fiona, we can see the hue of the ball shift from a standard green to a light blue. When an object visibly changes color when moving, we refer to that effect as the Doppler effect. Now, I understand many of you are wondering, I thought the Doppler effect was when a loud object gets closer, it has a noticeably higher frequency. While you geniuses are correct, the Doppler effect is actually defined as the change in frequency of a wave when the observer is moving relative to the source of the wave. You wanna know what else moves like a wave? That's right, light. We actually normally measure this phenomenon in stars to chart the universe's expansion. If a star moves closer to Earth, we will see the star's wavelength shift slightly blue. And if it moves away, it'll shift slightly red. Normally, this color shift is hardly noticeable to the naked eye, as it takes a fine-tuned instrument to detect the change in frequency. So, to see it go from bright green to light blue with the naked eye is ridiculous and practically unheard of. The visible light spectrum ranges between 400 and 700 nanometers. To put that in perspective, a 1% change in color, or just 3 nanometers, must have a minimum speed of 100 kilometers per hour, or 621 miles per hour. And if the ball shifts from a yellow of 603 nanometers to a blue of 478 nanometers, we are talking some serious speed. So to see how fast the ball is traveling, we can use the ever so popular non-relativistic Doppler shift formula. But I'm sure you've heard of it. We will only need a little bit more information to complete this equation. The speed of light, or c, and the receiver's velocity, which in this case would be 0, as Fiona is practically petrified. Additionally, we're going to quickly convert our previous values for yellow and blue from nanometers into terahertz, with our yellow equal to 497 terahertz and our blue to 627 terahertz. And after plugging all that into our formula, we get a tennis ball flying at, drumroll please, 22.8% the speed of light, which for all you math lovers out there is a little bit over Mach 1. For real though, 22.8% of the speed of light is approximately 68.4 million meters per second, or 152 million miles per hour. So then, how does this godlike tennis ball compare to your favorite anime characters? Well, Kuro-sensei may seem fast like a Mach 20 machine teaching students, but in a comparable battle of speed, that is only 15,354 miles per hour, or only 0.0022% the speed of light. The same goes for other OP characters like Gojo and Mashle, who, while are fast, are not nearly as fast as this ordinary tennis ball. And that's not to say that this tennis ball is faster than all of your favorite anime speedsters. Just take Shinra from Fire Force, Julius Novachrono from Black Clover, or Saitama from One Punch Man can easily achieve the speed of light without breaking a sweat. Hell, most of the characters in Dragon Ball are easily faster than the speed of light. So while this tennis ball is one of the fastest objects in anime, it is still nowhere near close to beating out some of the fastest people in anime. But it does set some serious precedent for the rest of the anime genre. Remember, this light speed is only possible due to animators translating manga into visually stylish and appealing depictions of speed. So I'm afraid to ask, but do we see this effect anywhere else? Well, look no further than almost every aerial fight. Because they're fighting at a distance, animators often switch to an image of two lights bouncing against each other in the night sky. And in cases where these characters are fighting without aura, nen, or chakra to make them glow a little bit, we can assume that they're achieving near the speed of light. This extends into almost every anime you can think of, with anything moving even slightly fast, as this animation technique has become commonplace due to its visual effectiveness at portraying speed. So while I may have found the fastest object for now, I'm sure that you'll be able to find objects doing the same after watching your favorite anime.